That's what about. No, we went to Dorks. Well, I went to Dorks. Super network. That the John Chamber see what's going on. We had one of the largest groups of people that fascinated that.
Good day, everybody. I'm Rotarians from the Rotary Club of Westwood Village. Curtis Smith, it's good to see you. Welcome. Oops, wrong one. Which one do I hit? Okay. So for those of you that don't know, excuse me, the Salvation Army is associated with donuts because of what is known as the donut lassies. It was a group of women who served donuts to soldiers during World War I. These women.
The mic.
It must be my voice.
Soft spoken. No, soft spoken.
Never. These women were Salvation Army volunteers who provided donuts and other services to soldiers in the trenches. They were the only female non-military personnel stationed on the front lines. The donuts were a morale boost for the soldiers and helped to popularize the donuts in the United States after the war. Anyone here that's a veteran? Please stand. You're a veteran, please stand. I'd like to honor you today and thank you for your service. Tia will be around in just a minute with a donut and a rose. So Tom, where were you?
I was a medic in the U.S. Army.
What year?
1860. I thought it was about a short minute.
What year?
1961 to 67.
61 to 67. Great, thank you. Curtis?
I was in the Air Force from 66 to 70 in continental United States, Thailand, and Great Britain.
Oh, well, thank you for your service. Christine?
California International University at Carolina. 230 Roadmaster, aerial firefighter, and tactical aerial patrol flight.
Well, thank you all. All right, so for today, we want to thank Nancy Cohen for greeting. Robert Simon, please lead us in the pledge.
Please rise and face the flag. Repeat after me. I pledge allegiance to the republic. One nation under God, indivisible, with
Thank you, Robert. Class President Ed Jackson, thought for the day.
Yep. Good afternoon. This election cycle, we saw the rebirth of the legend of seafood. Many in the country, around the world, and this country hope that it will make it a better world. Full disclosure. My grandfather, Thomas Swan Holden Sr., came from Texas to save his life. That's another story. Leaving the family farm, the quarry, the oil fields, as a son of a Methodist minister with 23 brothers and sisters, he being the eldest of the last 12 from his father's second wife. I guess he needed farm workers, so he had a big family. And he was a Republican, so we were Republican. And Grandpa would proudly say he never voted for a Democrat except for Lyndon Baines Johnson. And can you guess why? Yes, because he was from Texas. But no one else got his vote. And so from there, when he died, we received telegrams from President Nixon, President Reagan, and Kenny Hahn, to name a few of the people he worked with to make America great. Back to present time, in August, the UK and Northern Ireland also had race riots. I don't know if any people here know about it, because it isn't something that we would talk about, because it didn't fit the mold of what we think who leads race riots. This was a different group. And there was a headline from a great man that everyone knows now. His name was Elon Musk. He said, it's inevitable that we're going to have civil war. And then I wake up this morning and I find out that he's now part of the United States government. He has a title as co-chairman of Efficiency Department, whatever that means. But anyway. And then I found out that there's a Fox newscaster that's going to be the Secretary of Defense, and he doesn't even have any operational experience. Last week at Madison Square Garden, I heard these terrible jokes about garbage and Black people who supported Trump carving watermelons for Halloween. One thing that my dad did teach me was, and he was a man of few words, was never to become a punchline for a joke. So I already have a problem with that, no matter who you voted for. I was never a jokester because I didn't feel like putting people down to build up my self-esteem. And I don't think I'm really that funny. Some of you may think so. I don't think I really am that funny. Well, as we learned, and how I learned, was that no matter who was in the Oval Office, we all were going to make it through the next 4 years. All you had to do was make it through the last 4 years. But what happened the last time, I would say normally this was true, but from all the blah, blah, blah from the 45th administration that constantly came out every day, the sky was falling. I don't know why, but it was. And supposedly China releasing their weapon, COVID-19, many people died in the world. including my best friend, and I got sick. Ending my thought for the day, if we really want this country to succeed and for us to live to tell about it, we have to start being a good winner, especially if your man is in the presidency. We have to stop the stupid joke, the Democrats and the rats and the bats. I don't care. Personally, none of them have been my friends. But if you have friends in each party, that's good for you. So we have to stop that. And what we have to start doing is honoring what yesterday was, November 13th. It was World Kindness Day. We have to start being kind to each other because we're the only ones that are going to help us get through this. Not Washington, not California, where we are, our community. So that's what we have to do. And God bless America. And may we all have great 4 years ahead of us.
Thank you.
Look.
Thank you, Past President Ed. There is no song today. Past President Ed Bob could not make it. And thank you to Janet Schwartz for writing The Windmill. Welcome, Zoomers, Marsha, Michael Newman, Chris Bradford. Good to see all of them. There's Steve Shear disappeared, but he's, oh, there he is. That's Steve Shear. Welcome. All right, so today we have birthdays and anniversaries. I don't think I can read this. Okay, birthdays. Sunda Grunquist, Nevin Sankin, Bill Rowan, and people that have disappeared, Suk and Dwight Dukla. Anybody hear from them? Where'd they go? They just kind of fell off the face of the earth. Anniversary, Sunda and her husband Mark, and Chris and Rose Gaynor. Okay, Rotary anniversaries, Mark Brogo, 19 years.
Already?
Already.
Wow.
Phil Gabriel, 12 years.
All right.
Thank you. Brian Whitney, 14 years. And Nathan McCready, 7 years. Wow. Time does fly. So happy celebration to all of you. All right. So here is an article you can reach on the Los Angeles Times about President Ben's business. It was free advertising for him. It's a very nice article if you want to go in and read it. And to me, it's a very findable moment. Now, if I'm not mistaken, past President Steve, what was the deal?
Well, I talked to Ben about this the other morning. He said this cannot go without a fine. He said, all right, $25. I go, no, that's not satisfactory at all. So the deal we negotiated, it took our lawyers many hours for this deal, but we made this deal. It's a minimum of $50 to a maximum of $250. So for every client over over one, he will pay another $50. So it'll be, if it's 5, it'll be $250. If it's 6, so a minimum of $50, maximum of $250.
And Terry, just as an FYI, there's a business in Brentwood that wants to bring in how many new members?
15.
15. So we're already there. 250. All right. So if you haven't had a chance, go into the LA Times and read the article. It's really quite good.
Today? No, last couple of days.
No, last couple of days. Yeah. It was about 2 days ago, I believe.
I saw it online. I didn't see it in the actual paper, but I saw it online. It was online article appeared 3 or 4 days before it's paper. So
We also have a new grandchild in the club. Past President Mark Roper, would you like to stand up?
Thank you.
So Marcy had
She had a baby girl, Vivian Beth Shaker is her name, born yesterday at 9:45. weighs 5 pounds, 15 ounces. And had to go to the NICU because a little loss of blood, so they had some transfusions, but I just got pictures. Marcy's for the first time able to sit and hold the baby in the NICU, not in the room yet, and just feed the baby. And so
Fabulous. Congratulations. Terry, what do you think the fine is worth for being a new grandfather?
Rounding up to $60.
60 bucks?
I'll double it if I can dedicate the other half to Tom's barber.
All right, $60 it is. What with Village Rotary Club announcements? November 17th, did you want to touch on real quick? The UCLA Rotaracts are hosting high school students with a tour of the UCLA campus and a project.
So the people on Zoom can understand what you're saying.
All right, yeah, so I was able to talk with Chris, Shireen, and other, oh, okay, a little louder. All right, yeah, so I was able to talk with Chris and Shireen and other district members about the plan for Sunday, so I'll have a lot more concrete details. So like what I said last meeting, it will be starting at 10, but setup will be begin at 9:30. And we will have first like a panel where we have a panelist. I think Joseph was able to contact Brady. I forgot his last name, but yes, but he will be the main panelist. But then we will be breaking off into groups. So we will have the interactors kind of like mingle with both the Rotary members and with the Rotaract members. So that's your guys' opportunity to connect with them and to share some of what you know. After that, we will be having community service event. It's going to be blanket making. So I see that you guys are going to be doing blanket making later in the day. So, you know, more blankets for everyone. And then after that, we will be having, yes, we will be having lunch. Lunch is fully provided by, I think it's Patricia, but I have to double check. So lunch is fully provided. And then after that, we will have a tour. Depending on how many Rotary members are there, we will be splitting everyone off into different tour groups. So we will have interactors, Rotaractors, and Rotary members in the tour group. So if you guys want to continue chatting with the interactors, then that's a perfect opportunity to do so. And then we will be wrapping up at 2, and then cleanup will be ending at 2:30. So you guys are free to drop in anytime during that process from 10 to 2. And if you guys want to come, we would love to have you guys there. Love to have you guys interact to connect with the interactors. Yes? Yeah, so we will be in Ackerman, I think it's ballroom. I had to check, but it's in Ackerman, it's on the 2nd floor, and it's not the grand ballroom, but it's the one to the side of it.
That's north, south, east, west.
Right in the middle, yes. Yeah, so Ackerman's right next to the Broom Bear, you know how there's the UCLA store? Yeah, it's gonna be over there. But if you guys are having trouble, we will be picking up people from the engineering turnaround from 9:30 to 10. So if you guys want to meet us there, we will walk you guys up to our official meeting location.
Great, thank you. Also on November 17th from 10 to noon, District 5280 will be making blankets at the Collins Cats Y. Thank you very much, Erin, for children dealing with all kinds of kidney diseases. And they need volunteers for that as well. So Collins Cats Y, Sunday from 10 to noon. November 21st, again at the Collins Cats Y, MCA, they are in need of volunteers to pack food to give out to those that need it, especially Thanksgiving dinner. Correct, Aaron, week from today?
Yep. Got a lot of food coming.
I'll do it.
Some turkeys, not including myself.
I'll do it.
Great. And it starts at 8:30, correct?
Yes,
And it can go up to noon. You can stay for as long as you want or come at any point in time in between.
What's the date on that meeting?
Thursday, November 21st.
We still have a rotary that afternoon here.
Oh, yeah.
As far as I know, yeah. All right, announcements continue. December 5th here at Hillel from 5 to 7, 7:30-ish. We will be hosting the district governor. We invite you as well as the spouses, neighbors, friends, the more the merrier. It will be a baseball theme, so it's a casual dress. Wear your favorite jersey if you have one, or borrow a jacket from Mark Rogo, he's got plenty. December 12th is the shopping spree, the famous shopping spree that this club is known for, taking the Westwood Transitional Village children shopping. And that will be from 5 to 9 p.m. on December 12th. You'll meet over at 1401 Sepulveda at my office before we take off for dinner. Anyone interested in participating, please let David Stover or me know. Bill?
Yeah, it's getting to that time we need to start with, day no. So we can have a count. How many kids do you think we're gonna have?
Depends on how many Rotarians we have. We can get up to probably 15 to 20, so it just depends on the number of Rotarians.
And Diane, should we have a raise of hands right now? I mean,
Sure. Does anyone now plan to attend that event?
Well,
Actually, I'll have my wife wants to do.
oh, right.
And Benjamin will be there, I know that. Yes, anybody online planning to attend?
Diane, we typically need more than 11, or about twice that, right?
So normally we have between 15 and 18. Yeah. And those of you that aren't planning to participate, $100 donation towards the bus would be greatly appreciated. Hint, hint. Okay, December 19th, also here at Hillel will be the Rotary Club of Westwood Village holiday party of December, yes. So dress festive, come with an unwrapped toy or stuffed animal because we will be donating to both Toys for Tots and the UCLA Children's Hospital. And if you have a raffle gift you want to give, scrubs, bottle of wine, bring it on, and we'll have a raffle.
Time then, regular lunchtime.
Regular lunchtime, yes. Next week's meeting, Father Gil Martinez and Rabbi Eric Sherman will be presenting. I don't know what that's about or who got them, but come enjoy, I believe, what will be an interesting conversation. All right, anything else before we start the program? Questions, comments, announcements? Yeah.
We're leaving before the next meeting for eventually a destination wedding, family wedding in Sydney.
Oh, right.
But before that, we're going to spend a few weeks in New Zealand. So see you all after December 15th.
There you go.
Well, once again, maybe that's a findable event. I mean, a destination wedding. Oh, okay. All right. Yeah,
I think it's worth it.
$50. All right.
Hey, you volunteer.
You tried to test.
Well, yeah. All right. Anything else? Any other comments, questions, announcements? All's good to go. All right. Past President Tom Barron, would you please introduce our speaker?
Before I introduce our speaker today, Jessica Spake, I'd like to acknowledge two guests from the Carnegie Science. And that's Erica Clark, whose title is Strategic Initiatives Coordinator. Now, it sounds like she handles the cruise missiles. It's got a tremendous asset to our club because we've had speakers here since 2017 when I first came in, John McKay, et cetera. And also James Morris, who's the Senior Development Officer for Carnegie Science. And we can give $2 you want to give to the God. With that, I will introduce Jessica Spake. In 1889, the famous industrialist and philanthropist Andrew Carnegie wrote the Gospel of Wealth, encouraging the rich to use their riches to improve society. True to his word, eventually, through another organization associated with Carnegie, the Carnegie Science Obsevatories was created and funded by Andrew Carnegie's, what is the organization?
Carnegie Institution for Science.
Through the I was going to say Carnegie Foundation, but it's another.
It's really Carnegie Science, different than the foundation.
Yeah, it says Carnegie Science.
Many things.
We have been privileged to hear John McKay speaking on various subjects of astronomy. But today, we are again privileged, but this time from another astronomy expert, Dr. Jessica Spake. She received her PhD in astronomy from the University of Exeter in the United Kingdom. Jessica is a recent arrival to Carnegie Science, having served previously at Caltech. In 2018, she made the first successful observation of helium in a planet outside of our solar system. I quote Jessica, "I'm really fascinated by what detections of helium can tell us about the complex conditions of exoplanet atmospheres." You know, I've often wondered about that myself. Seriously, her area of study is exoplanets, that is, planets beyond our solar system. Actually, this happens to be one of the hottest topics in astronomy today. Dr. Spake analyzes which exoplanets retain or lose their atmospheres, research that will provide new clues in the search for life beyond Earth. I know a couple of people who I think are outside that solar system. As an aside, Jessica works with homeless children. As Rotarians, I'm sure we would appreciate some insight into what she does to help them. Please give a warm welcome to Jessica Spake.
Thank you so much. I think that might have been the best introduction I've ever had. I appreciate that. Thank you. Yeah, thanks everyone so much for being here for this talk. Just in this first slide, I've just written some of the names of the people that I've been working with, because although I'm the only person on this group standing here today, science is a very collaborative effort, and it's taken a lot of people to get to where we are today, which I'll show you about. So to start, I invite you all to relax for a minute. It is very loud. Relax and enjoy the sound of planet discovery. This picture shows you where in the sky we've discovered planets around other stars. The sound that you hear tells you the orbital period of the planet, and the size of the circle tells you the planet's size. And this patch of sky here is where the Kepler Space Telescope looked and discovered thousands and thousands of exoplanets, 5,000 in the last 30 years. Now, this monumental feat of human achievement has been driven by the work, the collaboration of thousands of people professional astronomers like myself, engineers, generous donors, citizen scientists, all the support staff at Carnegie Observatories and many other places where people study these planets. Now, how do we actually detect these things? So trying to take a direct picture of a planet around another star is like trying to take a picture of a pea that's held next to a flashlight that's held a mile away on the top of a hill. Stars outshine their planets by up to billions and billions of times. And so we've only actually managed to take direct images of about 20 planets around other stars. Here is one of them. This is actually the first ever movie of planets orbiting its host star. And you can see this is done by blocking out the star's light in the middle. And here are the planets going around them. So that's not how we find most exoplanets. That's not how we found thousands of them. Instead, we use indirect methods. One of those indirect methods is the radial velocity technique. Now, we know that gravity keeps a planet in orbit around a star, but the gravity of the planet will also affect the star itself. And every time the planet orbits, it will pull on the star and make it wobble like this. And we can actually go and see this wobble back and forth of these stars in the sky. And I'll talk to you a little bit about how we do that in a bit. But the size of the wobble can tell you how massive the planet is. So that's one way, without even seeing these planets, we can know that they're there. The other technique is the most popular technique. This is how we found the majority of the 5,000 planets that we now know today. This is called the transit technique. And it works basically like a solar eclipse. So all of the planets in the sky are randomly aligned so that some of them may be aligned just right that once each orbit, the planet will pass in front of its host star. And if you take your telescope, point it at the star, and measure its brightness over time, you get these little dips in the brightness every time the planet passes in front of it. And this is a transit event. And now the depth of this transit can tell you how big the planet is. And so that's another way we can know planets are there without directly seeing them. And this is a scientific plot of kind of a summary of many of the planets that we've found so far. So the planets towards the top of the screen, the planets up here, they're pretty big. So this is ordered in size. These are around, you can see Jupiter here. These planets are around the size of Jupiter. And the planets that are close on the left side of the screen, these are closer to their host stars. Planets that are further away are on the right side of the screen. And you can see Earth, Venus and Mars over here. These are pretty small and pretty far away from our sun. So you can see all of these planets that we found where we've been able to measure their size. None of them are in this area of the plot here. So we haven't actually found any planets that are very similar to Earth yet, because it's very difficult to do so. What I want to tell you about also is this line here tells you the size of Neptune. Now, Neptune, if I drew it on this plot, would be off the screen over here. It's very far out in the solar system. And it's a gas giant planet. You can see it's much bigger than the Earth. It's up here. Before we discovered planets around other stars, we didn't think it was physically possible to form planets between the Earth and the Neptune size. These kinds of planets here are actually the most popular kinds of planets that we see in the universe, somewhere between the size of Earth and Neptune. And let me just show you a little picture of what we think, why we thought this. So Earth is a rocky planet. It's basically a wall of rock with a little sprinkling of ocean and atmosphere on top. Inside Neptune, we think there is essentially another ball of rock that has got big enough that it swept up all of the gas around it, and it ran away into this giant unstoppable accretion, led to it becoming much bigger than Earth. We didn't think anything else could form in between this. We thought if the rock is too small, it can't scoop up a lot of gas and it remains small. However, what we found is this is really the most common size of planet, actually somewhere between this size and this size. We actually have no idea what they're made of. We don't know whether they're large, much larger rocks that have somehow not scooped up a lot of gas, or we don't know whether they're like Neptune, very gassy, lots of hydrogen, helium, and water that have somehow shrunk down to be a little bit smaller. It's one of the most enduring mysteries in exoplanet science. we found basically planets of every size that you can imagine. And right now we're trying to figure out, what do they look like? What are they made of? Could any of them host life? These aren't real pictures of exoplanets. These are just some of our artist impressions of what we think they might look like based on real science. And you can see there's real diversity of color here because we think different chemicals in the planetary atmospheres would give very different colors to the atmospheres, give you very different colored sunsets, for example. We've also found planets where it rains droplets of iron. And we found planets where there are clouds made of rubies and planets with winds that whiz around thousands of kilometers an hour, much faster than anything in our solar system. The diversity is staggering, way more diverse than we could have possibly expected before we started to find these. Many of these planets are just nothing like what we see in our solar system. This selection of planets are the most Earth-like ones we've found so far. And I'm showing you here compared to the size of the Earth and the size of Neptune. So they're all smaller than Neptune, and some of them are actually quite similar to the size of Earth. Also, all of these planets on this picture here, and again, all of these, they're not real pictures. These are artist impressions of the planets. We think they might look like this. All of these planets are actually around a similar temperature to Earth. If they do have atmospheres on these planets, it may be the right temperature for liquid water to collect on the surface. And that's one of the key things that we're looking for in the search for life outside of the solar system, because all life on Earth required water. However, a problem with those planets. All of those planets orbit stars that are kind of like this. They're very small. Here is a very famous system, the TRAPPIST-1 planets. This is the size of its star compared to our sun. This is why we're able to find them, actually. Planets around smaller stars are easier to find. We found 7 Earth-sized planets around TRAPPIST-1. These middle 5 are within what we think might be the habitable zone if these planets have atmospheres. This is an incredibly beautiful system. We didn't think you could get 7 rocky Earth-sized planets around such a small star. It was a real surprise to discover. We're not sure if these can hold life on them. Just as a fun comparison, the star is so small, it's about the same size as Jupiter, the biggest planet in our solar system. And the moons of Jupiter bear some resemblance to these 7 planets all in a line, because they orbit the star about the same rate that the moons orbit Jupiter. And here's an illustration of the actual size of the system compared to the size of the Earth's orbit around the sun. And we have many more planets we have 7 more planets in the solar system, some of which orbit much further out than I'm able to show on this slide here. And this is the TRAPPIST-1 system. This is the size of the outermost planet. You can see it's so much closer in to its host star. But the reason that Earth and these planets are about the same temperature is that these small red stars, like TRAPPIST-1, these are so much cooler than the sun. And so you can get much closer into the planet and still have a nice, comfortable temperature than you can for the sun. These kinds of planets are so much more easy to detect. The planet passes around the star once every 5 days. So you only have to watch the star for 5 days to see one of these transit events. You would have to watch a star for 365 days a year and see nothing for most of those days to see a single transit of the Earth around the sun. Also, because the orbit is much smaller, you're so much more likely to pass in front of the star if all these systems are aligned randomly in the sky. The chances of having that nice alignment where you see that eclipsing event is just so low for planets like the Earth. And this is why it's right now, it's very difficult to find truly Earth-like analog systems. So we found many of these warm planets around smaller stars. These small stars can be very violent places. This is an image of the birth of planets around a very young star. The planets are actually being born in this line here. What this line is a swirling disk of gas that's surrounding a very young star. And that's where the planets are being born, in this swirling disk that you're seeing kind of edge on. And the star is in this very center here. But look at this, like absolutely giant hourglass, very violent environment with a lot of light and a lot of swirling gas and dust. Planets are born in violent places, and they also live next to pretty violent hosts. This is a video of the sun at UV wavelengths. You can see these giant explosions. This is a coronal mass ejection that happens pretty often for the sun. I don't know if you can see, but I've actually moved the Earth a lot closer in this tiny blue dot here. That is the size of the Earth compared to one of these giant coronal mass ejections. These coronal mass ejections can strip away an atmosphere. This is a picture of a planet here, and these lines are the magnetic fields of the planet. This is a real model, a real simulation of some people that were doing testing how a planet's atmosphere reacts to one of these explosions. And you can see this like stream of stuff, charged particles, radiation that comes streaming towards the planet and pinches down the magnetic field and strips away some of its atmosphere. So this is what I study. How does this happen for planets around other stars? Which planets are able to maintain atmospheres for billions of years, long enough to life to evolve? But which of them lose their atmospheres to space if some of them are so close to their stars that are very violent and may strip them all away? This is one of the most famous images ever. This is taken by the Apollo astronauts on the moon in the 1960s. People talk a lot about finding planets in the habitable zone of its star. That's where you think liquid water might survive on the surface of a planet. This is the moon. This moon is in the habitable zone of the sun, and yet it is a lifeless bare rock because it's lost all of its atmosphere. So we really need to know which planets are lifeless balls of rock like this, and which ones are gems of life like the Earth. And to do this, I study exoplanet atmospheres, and I'm looking at the very edges of the atmospheres. I'm looking at exactly where the material is escaping into space. This is an image of the Earth taken at UV wavelengths. So this is the ultraviolet wavelength. It's not visible light. It's much more energetic. You need special telescopes to observe it, like the Hubble Space Telescope, or NASA's Solar Dynamics Explorer, which flew in the 1970s. So this is a pretty old image. This is a top-down view of the Earth, and you can see the glowing aurora here. And this is a side view of the Earth, where you can also see this little hat, the aurora. But surrounding it, there's this red glow. Now, this red glow is hydrogen, element number 1, the lightest element in the universe, the most abundant element in the universe. And you can see this is the Earth's atmosphere. This is the top reaches that extend out thousands of kilometers above the Earth's surface. And it's very gently trickling off into space. The Earth is losing its atmosphere at a rate of 3 kilograms per second. At that rate, it would take 40 billion years to lose a significant fraction of the Earth's atmosphere. So we are fine. We are not going to lose our atmosphere. But this is kind of how we can study atmospheric escape, by looking for these giant clouds surrounding the planet. And I've spoken a little bit about how this is, UV wavelengths. And this is the most difficult slide. You can ignore this part if you want. This is definitely the hardest science part of the talk that we're going to do. All atoms are made up of a nucleus. Here is a hydrogen atom. It has a proton in the middle, and it's surrounded by electrons, and they are in these shells surrounding them. And they can absorb a tiny particle of light at very specific energies. And I don't know if you remember prism experiments in class, where you take a prism and you shine light through it and it splits it up into all the different colors. And that's called spectroscopy, and that's what we're doing. We take the light, we split it up into all of these different colors, and each of these different jumps between these levels corresponds to a different color. So we're just seeing what color does the planet block out the most amount of light. If there is a lot of hydrogen in the extended atmosphere of a planet, it will block out light at a very specific color, only a very specific color. If you looked at this invisible light, you would not see this big halo surrounding the planet. We look at this very specific color where hydrogen blocks out a lot of light. And that's how we find these huge extended atmospheres around planets. Some people feel mildly traumatized when they see a periodic table of elements, so I hope not to do that to you today. Don't worry. I just want to point out, it's not a test. Hydrogen over here is the most abundant element in the universe. It has 1 electron, 1 proton. Helium here is the second most abundant element in the universe. 2 electrons and 2 protons. So previously, we'd not been able to study atmospheric escape in great detail because we'd only been able to use hydrogen to see this escaping atmosphere. That's very difficult, and you can only do it with the Hubble Space Telescope, which I'll show here. And before I started my PhD, we'd only found 5 escaping atmospheres with this hydrogen line. And I'll show you, this is the first time it was used to find an escaping atmosphere around an exoplanet. Do you remember that, the line I showed you in the beginning when the planet blocked out a bit of the star's light? That's this line here. If you look at the regular planet, it will block out this much light. But when you look in this special line of hydrogen, these data points here are measurements taken with the Hubble Space Telescope. And you can see it goes much deeper. If you drew a line, it would be so much deeper down here. We can see that this planet has a huge cloud of hydrogen surrounding it and escaping it. When I was in grad school, as Tom said, I completely accidentally discovered helium on an exoplanet for the first time, element number 2. People had been looking for it actually for 20 years on exoplanets, but just weren't able to find it. We looked at, basically just used a different color to look for it by accident and found it. Here is the size of the planet when it normally passes in front of the star. Here is the size of the planet when you look at it in the color that helium blocks out. So it's huge. There's this huge cloud of helium surrounding the planet, and it's escaping the planet, and it looks like this. This is a top-down view of the planetary system. Here's the planet here. It goes along its orbit here, and there's this giant stream of helium that's being blasted away from the planet. Since we made this detection, we've found 19 more planets with helium escaping from them. And the reason we can do this is because you can do this kind of work from the ground with ground-based telescopes, like these absolutely beautiful instruments, the Magellan telescopes in Chile, run by Carnegie Science, which I'm incredibly grateful to use. This is a really major reason why I wanted to come and work at Carnegie, because now I have abundant access to use these telescopes, and I can make many, many observations of helium in these exoplanets. And we can learn more about which planets are losing their mass and how much of them have these giant clouds streaming away from them. This is also me, first day of work in the same outfit. I realize this makes me look like a Simpsons character. I do have other clothes, but I was very, very excited to start working here. We're also hoping in the future success of these very large new telescopes, 30-meter telescope, one that Carnegie is hopefully helping to build. One of these mirrors is basically a similar size to these large mirrors on these telescopes here. And what we're going to do is stack 7 of them together and point them at individual planets. So far, the stuff I've been showing you has been focusing on a lot of big planets because those are the easiest ones to detect. But hopefully, with these large telescopes in the future, we're going to be able to target much smaller planets, maybe planets like the Earth. And we'll maybe be able to tell you whether Earth-sized planets around those small, cooler stars are able to host life on them or not. We're also going to be able to do this with the James Webb Space Telescope as well pretty soon. Although the precision that this telescope reaches may not actually match these large 30-meter telescopes in the future. So I'm very, very excited for the future. Here is M106. It's one of my favorite images of galaxies because I think it's just incredibly beautiful. You can see within this galaxy, there are hundreds of billions of stars. There's also a bunch of gas and dust that's all swirling around. And this is my background on my computer, which when I very rarely close all of my tabs, I occasionally get to see. And I find it very inspiring because we have only started to explore a very small region of our own galaxy, of a circle about this size. That's where most of the planets that we've ever found within our own galaxy are. So within even our own galaxy, we have an entire galaxy to explore still. And this is an image taken with the James Webb Space Telescope recently. This is a very deep field. It's a patch of sky that is smaller than the size of the full moon. So if you hold your thumb out at the night sky, it's a region of space smaller than your thumb. And within this image, there are over 10,000 galaxies. And in each of these galaxies, there are hundreds of billions of stars. Each one of those stars we found probably has at least one planet. The number of planets that are out there is absolutely mind-boggling. I feel like there's probably some life out there. It's very hard it's going to be very hard to detect, but I think the chances are pretty good. We just have to build good telescopes that are going to allow us to do this. So yeah, this is my dream for us to continue with this work and maybe reach some of these galaxies in the future. Yes?
What are the distances involved between here and the places you're looking at?
Very good question. So the planets that we're looking at are around stars that are very close to us. We have discovered a planet around our very nearest neighbor, Proxima Centauri. It's about 4 light years away, and it takes 4 years to reach us from that star. We wouldn't be able to cover those distances. Most of the other planets that we found are within around 100 light years away. That's kind of this is about 100 light years across. But you can see galaxies are thousands of light years across, and the distances between galaxies is even vaster, millions of light years between galaxies. So they're pretty vast distances.
So some of the planets and stars you see, we maybe seen the light maybe 100 or 200 years ago. So we don't even actually know if the stars exist today.
Exactly. So the lifetime. Yeah. So the further away you look in space, the further back in time you're looking. That's exactly right. So for the planets that we look at, it's true. We're looking at them as they were 100 years ago. So on human lifetimes, that's a huge difference. Who knows what's going to happen to us in 100 years? On a planetary scale, it's a blink of an eye. There's been life on Earth for a long time, a lot longer than 100 years or so. And so we're kind of the planets that we're able to access now, the timescales don't change too much. But when you go further to look at galaxies, it's true. Some of those planets that you observe might even exist now. Yeah.
So 5 minutes.
5 minutes. All right. I will briefly mention the other work I do at the weekend. 1 in 20 children in California doesn't have a home. When I moved to California, I was really, really struck, actually devastated to see the number of people struggling on the streets here. I had no idea what to do about it, but I started Googling, and in my Googling, I discovered just how many children don't have homes either. Many of them are in shelters, domestic violence shelters. Some of them also live on the street, on Skid Row, or in hotels, impermanent housing, very chaotic places. I just couldn't believe the numbers. So this is a slide from an organization I work with, which is called School on Wheels. And School on Wheels provides free tutoring to these children. The distribution of children is also unbalanced. Only 7% of the children served by School on Wheels describe themselves as white. And so this homelessness affects children of color at a far higher rate than other children. For the last 3 years, I've been working with a family. There are 3 kids. I have found it a life-changing experience. It's really, these kids are really wonderful. I like to talk to them a lot about science. I think it's nice to go out in the world and let people know I'm a real person. I do science. It's not scary. And I had to go away and to a conference. You know, when you're a scientist, you got to go away to conferences, you got to give presentations like this. Sometimes you've got to make posters. If you don't get a talk, you make a poster and someone, And Yusuf, the one of the kids I work with, was like, what's a poster? So we spoke about what a poster was, and he made his scientific poster. So he's been obsessed with titanoboas. They are giant extinct snakes that eat crocodiles. All of these facts, he designed this poster himself. He knew all of these facts off by heart. There's even some speculation down the bottom. Maybe Titanoboa eats megalodons. Megalodons was his obsession, giant sharks from the previous year. I'm not sure if they overlapped at all. But at Carnegie, what I'm really hoping to do is expand this work and reach many more children. And my real goal is to set up a program where we take busloads of children to the top of Mount Wilson, where we have the Mount Wilson Observatory, which has deep links to a beautiful, very important astronomical site for the history of astronomy. The universe was discovered here. And they have these beautiful telescopes, which I'm hoping to take and invite children in to learn about astronomy through this. Yeah, very happy to take any more questions. Thanks so much.
I'm with Carnegie Science myself, and I think I've wondered, we'll talk Jessica. I just wondered how many people have been to the Carnegie Observatory and knew about Carnegie Observatory before this talk. Very quick, elevator pitch. We're the oldest scientific organization in Southern California, founded in 1904 by George Ellery Hale, who was a solar astronomer. And it was Hale who built those telescopes that you can see there. The larger dome on the left is the one where, as Jessica said, the universe was really discovered by Edwin Hubble, who was a great Carnegie astronomer. He discovered that this little blur that he was looking at night after night had to be another galaxy. And before that, it was thought that the Milky Way was the entire universe, but it was Hubble who discovered galaxies beyond the Milky Way. So we have 5 different departments in the Carnegie Institution for Science. I'm a little biased. I think the observatory is kind of the crown jewel, but we have departments in life sciences and earth sciences as well. What I also mentioned to Tom is that I really hope everyone here can come visit in Pasadena. We're quite an amazing place. And Caltech, but Carnegie really gave rise to Caltech as we know it today, which gave rise to JPL. It's kind of lineage in Pasadena. There's more astronomy in Pasadena than anywhere else in the world today.
Just
So we art club plus other surrounding those apartments.
So just as an FYI, Tom is our social chairman, so he could set up the. Jessica, thank you so much. We have a token of our appreciation for being here today. We want to thank you. Same time, same place, next week. See you.
From the Boston Observatory in Chile, water.
And this is what the night sky looks like.
Thank you again. Wonderful presentation. We'll see you all the rest of you next week.
It's